Graphs of sine and cosine. Let's get started. So first, you're going to want to have some graph paper. You don't need actual printed graph paper. You can just use regular like notebook paper or blank paper. And I recommend that you label it like so. Along the horizontal axis, we're going to have little tick marks that are going to go every pi over 4 units. And then I'm labeling every second unit, pi over 2. So it would be that's pi over 4, 2 pi over 4, 3 pi over 4, pi, and then that would be 5 pi over 4, 3 pi over 2, and so on. Same thing going to the left, but then for our vertical axis, we're just going to go up 1 and 2, and then down -1, -2. Okay, the other thing that you're going to want to have is you're going to want to look at the unit circle. I'm looking at a table of values over here, and I'm looking at 0, pi over 4, pi over 2, and so on. And I'm going to look at the unit circle, and I'm going to identify the sign. So the sign of 0 is 0. So I'm going to plot a point at 0, 0 on the origin. Then pi over 4, the sign of pi over 4 is the square root of 2 over 2, which is approximately 0.707. So I'm going to go to pi over 2, excuse me, pi over 4, which is here, and then go up to about 0.707. So that's going to put me, just eyeballing it about there. Then at pi over 2, that's going to be 1. And instead of plotting, I'm just going to go ahead and fill out the table. Okay, so once again, I get all of these values from the unit circle, and now I'm going to plot them. So pi over 2 at 1, and then back to the 0.707, and then negative 0.707. And I have this collection of points, and then if I connect them, then I'm going to get a little something like that. It's sort of a wave, if you will. Now, let's talk about what happens if I were to go left. And let's just look at like negative pi over 2. The sign of negative pi over 2 is the same as the sign of 3 pi over 2, so -1. And then what about negative pi? Well, the sign of negative pi is the same as the sign of positive pi because they're coterminal, so 0. And then the sign of negative 3 pi over 2 would be the same as the sign of positive pi over 2, so +1. And then the sign at negative 2 pi is going to be 0. And if you connect the dots, you're going to get something like that. So this is what the graph of the sine function looks like. And you can imagine that if you were to carry on beyond 2 pi, you're going to end up with the same pattern of this oscillating curve. And there it is. So what we have is we have a maximum at pi over 2, we have a minimum at 3 pi over 2, we've got an intercept at 0, at pi, and again at 2 pi. This information is going to become important later on. When I think about the sine curve, I always think about these 5 key points. 0, maximum, 0, minimum, 0. Or in other words, middle, high, middle, low, middle. Okay? This is what's known as a periodic function. All of our trig functions are periodic functions, which is a function that returns the same value at regular intervals. So returning back to 0, and then it starts over again, and so on. So the period is the least amount of space in degrees or radians the function takes to complete one cycle. So for the sine function, the period is going to be 2 pi. We get one complete cycle of the sine function between 0 and 2 pi. So the period is 2 pi. Notice it's also the same as one revolution around the unit circle. The amplitude is going to be half the distance between the minimum and the maximum. So the maximum here is 1, the minimum there is -1, the amplitude is going to be 1. Another way to describe the amplitude is the distance from the maximum and its midline, if you will. So its x-axis, because we're going to shift this graph up or down. And so the midline could potentially be shifted up or down. Let's do the same thing for the cosine function. Again, looking in the unit circle, look at 0 and pi over 4 and pi over 2 and so on, and write down their cosine values. And there we have them. Now I'm going to plot those points. So 0, this time we're going up to 1. And then I'll connect the dots, and we get that wave. And then we can figure out if we were also to go to the left and we're considered the cosine of negative pi over 2, well, that would be 0. And then the cosine of negative pi is -1. The cosine of negative 3 pi over 2 is at 0. And then the cosine of negative 2 pi is 1. Connect the dots, and we get that curve. So we'll notice that the cosine has the same period. It still takes between 0 and 2 pi to get one complete cycle of the cosine curve. The amplitude is still the same. It's still 1. What's different about the cosine curve is now we're going from high, middle, low, middle, high. Those are my 5 key points of the cosine function. So again, high, middle, low, middle, high, just said that. The amplitude is 1, the period is 2 pi, you should write that down. And then this is what the graphs of the sine and the cosine look on the same coordinate plane. So you can see, let's talk about where these graphs intersect at each other. What would be that measurement in radians where they intersect? Yeah, it would be pi over 2. That's in quadrant 1 with the sine and cosine the same. And then over here, this would be 5 pi over 4 because that would be in quadrant 3 where the sine and the cosine are the same value. And then they intersect here and here again. So some of the basic characteristics of the sine and cosine curves are as follows. They both have a domain of all real numbers, or negative negative infinity to positive infinity. They both have a range from -1 to 1 inclusive, meaning it does actually go up to +1 and it does go down to -1, both the sine and the cosine. The period is 2 pi for both of them. Your x-intercepts for the sine function are going to be every multiple of pi. So if we look here, we're going to have an intercept at 0, pi, 2 pi, there'll be another one at 3 pi, over here at -pi, -2 pi. So those are your x-intercepts. And then for the cosine curve, it's a little bit more complicated because it's going to start at pi over 2, and then you're going to add pi to get the next one. So for example, pi over 2 plus pi takes you to 3 pi over 2, plus another pi would take you over here to 5 pi over 2. If you were to subtract pi from negative pi over 2, you get negative pi over 2, and then subtract another pi, you get a -3 pi over 2, and so on. So that's where your x-intercepts are going to occur. Your y-intercept for the sine function is at the origin. There's only one y-intercept. And for the cosine function, the y-intercept is at 1. So 0, 1 for cosine, 0 for the sine. Odd even functions. You would have learned this in Algebra 2, that an odd function is one that has symmetry about the origin, which is what we have here, symmetry about the origin. And then the cosine function is an even function, has symmetry about the y-axis. So let's just go back and look only at the cosine function. You can see that it does have symmetry about the y-axis. If you were able to fold my iPad screen along the vertical axis, then this portion of the curve would lie on top of that portion of the curve. So it has symmetry about the y-axis. So it makes it an even function. The sine function, though, here, the sine function, that's not the case. If you were to fold along the y-axis, you would not have this part lay on top of that part. And same is true, it doesn't have symmetry about the x-axis either. What it does have is it has rotational symmetry about the origin. So if you were to take this whole thing and rotate around, like if I turned my screen upside down 180 degrees, then it would look exactly the same. Another definition of even and odd, if I will remind you from Algebra 2, is that odd functions are defined such that f of negative x is equal to negative f of x, and that even functions are such that f of negative x is equal to just f of x. So in the context of the trig functions, for cosine, which is an even function, cosine of negative pi over 4 would equal the same thing as the cosine of pi over 4. So if you think about the unit circle, that's going to be equal to the positive square root of 2 over 2, and the also equal positive square root of 2 over 2. But then so the cosine is even. But then for the sine function, it's odd. So if you did the sine of negative pi over 4, that's going to equal to the opposite of the sine of positive pi over 4. So sine of negative pi over 4 would be negative square root of 2 over 2, and then the opposite of the sine of pi over 4 is negative square root of 2 over 2. So the sine function is an odd function. All right, if we were together in the classroom, I would have you click on this link. It is case sensitive, and then you could do a little bit of dragging of some sliders on Desmos to see how the graphs change. And I would have you fill out this table, but for this purposes of this video, what you would have discovered if you had done that, and you're welcome to do it, is that this value in front of the sine function, that's going to always give you the amplitude. And technically, it's the absolute value of it, because if this was negative, then it's going to reflect in the x-axis. And then we can say that if the absolute value of a is greater than 1, that's going to be a vertical stretch. And if the absolute value of a is less than 1, it's a vertical shrink. So it's like if you could see my hand gestures, you're going to be squishing something. If you hold your elbows out parallel to the floor, one hand like at your eye level and your other hand like at your neck or your chin, and then you bring your hands together like you're squishing vertically, okay? So that's a vertical stretch or a vertical shrink if you move your hands away from each other. And then for your period, it's actually going to be 2 pi divided by b. All right, I went ahead and opened up a Desmos page so I can explain a bit more about the b. So if b is 1, then you just get your regular sine function. And then if I make b bigger, then I'm going to get more waves where I normally had few. So this would be a horizontal shrink, again, with your hands. If you think about your hands being parallel to the wall or perpendicular to the floor, and you have one at your right shoulder and one at your left shoulder, and your hands are facing each other, like palms open, and you were just to move your hands close together. That's a horizontal shrink. And then pull your hands further apart. That's a horizontal stretch. So there's your shrink and then your horizontal stretch. And you'll notice that it does eventually, when it goes negative, it's going to reflect in the y-axis there. What happens is when b is equal to 1, you get one complete cycle between 0 and 2 pi. If b was equal to 2, then you're going to get two complete cycles between 0 and 2 pi. And if b is equal to 0.5, you're going to get 1/2 of a cycle between 0 and 2 pi. So that's why if you want to find what the period is, you're going to divide your b value into 2 pi to find out how long it's going to take to get the whole period. So again, 2 pi divided by b is your period. And if the b is greater than 1, it's going to be a horizontal shrink. And if b is a fraction between 0 and 1, it's going to be a horizontal stretch. C is known as your phase shift, which is basically the same thing as a horizontal translation. And if c is greater than 0, it's going to shift to the right. And if c is less than 0, it's going to shift to the left. So that's going to be very similar to what you've seen in other types of functions in Algebra 2. Your d value is the easiest one because it's straight up. If it's positive, it goes up. If it's negative, it goes down. It's just going to be a vertical translation, either shifting up or shifting down. So for number 1, we're going to analyze the graph. We're going to write down the amplitude, period, phase shift, and vertical translation when we're given the equation. So the amplitude is just going to be 3. It's whatever number is in front of the trig function. And then the period, remember, we're going to do 2 pi divided by b. Well, b in this case is actually going to be a half, because this can be written as 3 times the sine of 1/2 times x. So b is that value that's between the name of the function, the sine and the cosine, and then the x. So 2 pi divided by a half is going to be 2 pi times 2, so 4 pi. The phase shift, since we don't have anything that's being like added or subtracted here, the phase shift, there's not going to be any phase shift, so we just write none. And same for the vertical translation. There's no vertical translation here because we don't have any minus c from the x value or any kind of a plus or minus value outside the function. Try number 2 on your own and then check back. For number 2, the amplitude is going to be a half. The period is just going to be 2 pi because it's just 2 pi divided by 1. You don't have to write the 2 pi divided by 1 part because there's just a 1 that's understood here between the sine and the x. The phase shift is going to be right pi over 3. You can also just write WRITE. You can also just write pi over 3, and that would be understood since it's positive that it's actually moving to the right. So you can either say right pi over 3 or just pi over 3. You don't need to do both because it would be redundant. And the vertical translation here would be none. Okay. All right. Something that's worth noting here is that we are going to use this as our general form or standard form, whatever you want to call it, of the trig equation. Of course, you can replace the sine with the cosine, you get the same result. And this is the easiest one, in my opinion, because notice you've got the x is separated out with the c and is grouped together with the c. Whereas some resources will use this. They'll group the b, x, and the c in the same parentheses. And what's tricky about this one is you have to remember that you need to factor that b out away from the x in order to determine what the phase shift is. So the phase shift there would be defined as c divided by b. I prefer it to be this way, but you'll see in some examples that you need to factor out in order to answer the question, which is what we're about to do here. So these two expressions, these two equations are not the same. This is 2x minus pi, and this is 2 times x minus pi. So when it's written this way with like the extra grouping parentheses, then your phase shift is just going to be pi. But if it were written this way, you would have to factor out the 2 in order to identify the phase shift, which is just going to be pi over 2. Or like I said, you can just do c divided by b to get your phase shift. So for this one, you're going to need to factor out the 2 pi. So take a minute, pause the video and try this one. Okay, the amplitude here is going to be 3. Notice it's not going to be negative 3. The negative is going to make it reflect in the x-axis. But it does not affect amplitude. It's always going to be positive because it's a distance. The period is going to be 2 pi divided by 2 pi, so it's just 1. And the phase shift is going to be either you write negative 2 or you can say 2 to the left. Be careful that you don't say negative 2 to the left because that would imply a double negative and then it would make it going 2 to the right. Vertical translation, none. For our last example, we're going a little bit differently. We have the graph of the function, and we're going to write down the amplitude and the period and the phase shift of the function, and then it says if it's written in this form, find the values of A, B, and C. So pause the video and try this one on your own. Okay, looking at the graph, I can see that the amplitude is equal to 2 because the distance between the midline and the maximum or the minimum is going to be 2. Now for the period, it's a little bit tricky because you need to figure out that this has been shifted over to the right. If this is a sine function, the sine function has to start in the middle and then goes up and then, or it could go down and go middle, down, sorry, middle, low, and then middle and high in the middle. But this is going to be our starting point right here if we're saying that this is a, if this is a sine function. If it were a cosine function, you could certainly start here and just have it reflect. So if we're going to start here at pi over 2, we're only getting 1/2 of a cycle between pi over 2 and 3 pi over 2. That horizontal distance between pi over 2 and 3 pi over 2, of course, is pi units. So that's just half of a cycle, which means that you're going to get a whole cycle in 2 pi radians. So that means that your period is going to be 2 pi and equals to 2 pi divided by b, so that b value is going to end up being 1. I'm getting a little bit ahead of myself because I'm already answering a part of part B, the question. But again, if I'm getting 1/2 of a cycle between pi over 2 and 3 pi over 2, which is a distance of pi, then that means I would have to go a whole other, to get the whole cycle, I have to go a whole other pi, which makes the whole period would be 2 pi. Okay, and then they also want us to find the phase shift of the function. Well, as I already pointed out, that the starting point here would be pi over 2 to the right. So that means that the phase shift is just pi over 2. And you can say to the right there if you needed to. And now for part B, they want us to write the equation. Well, since the amplitude is 2, we know that it has to be the A value. So we're going to have y equals 2 times the sine, open parenthesis, the B value is 1. You obviously don't have to write that. And then x minus your phase shift is pi over 2. So that's your C value, pi over 2. And then, of course, we don't have a vertical translation, so we don't have a plus d. So you can write it like that and be done. If you wanted to clean it up a little bit, you can just write 2 sine of x minus pi over 2. And there it is. I do want to point out here, you'll notice in my answer key that you could alternatively think of this as actually starting over here at negative pi over 2 and then reflecting and going middle, low, middle, high. And so in that case, you would have to put the negative in front of the amplitude there, and then your translation would be pi over 2 to the left. So you could also have answered the question this way. There's actually many ways that you could answer this question that would give you the same function because of the nature of the periodic function.